Hello. Today we're going to look at domain and range and answer two of the big questions that we talked about yesterday. We're going to look at what inputs are possible and what outputs are possible. So before we get started today, you're going to need your notebooks. So get your notebooks out. You also are going to want to find this page from your packet. It should be near the back because it was kind of a last minute addition. So find this. You're going to need scissors just to cut the corners off of this page. And if you happen to have packing tape, grab the packing tape. If you don't have it, it's fine. But if you do, that would be great. Or if you don't, I think you could use a Ziploc bag too to make this dry erase if possible. So if you have those, great. If you don't, a pencil would be fine too. So let's get started. Now remember, if I write things down, that means I want you to write things down too. You learn by doing, so you want to process this information along with me, not just watch me do it on video. So we're going to be looking at domain and range today. So the big questions that we will be addressing is number one, what inputs are possible? What inputs are possible? So inputs in math have to do with the x values. Now, if you remember from graphing things, this is the x-axis. The x-axis runs horizontally, left to right. So when we're looking at what inputs are possible or what x values are possible, we want to think about how far to the left or how far to the right the graph goes. So the x-axis is horizontal. So we are looking at how far left and right. There's a little bit of lag in my smart notebook, so sorry about that. Left and right. Okay, and some things go on forever. Sometimes you'll have like a line that goes forever to the left or forever to the right. So there can be infinity involved in these, so we'll talk about that a little bit more. The other big question that we're going to be looking at today is what outputs are possible. So we call that range. Oh, did I put that we call that domain on the last slide? Let me go back for a second. So this is range. I'm sorry. Oh, this is domain. Domain has to do with your x values, how far left and right. Now we'll go to our new page. What outputs are possible? So these are your y values. If you remember from graphing, your y-axis is the one that goes up and down. It can go really high up or really low down. So y-axis is vertical. So we are looking at how far up or down. Well, let Smart Notebook catch up a second. How far up or down? And this is range. Okay, so domain goes with your x values and range goes with your y values. So you'll need to remember that. If it helps, you know how x comes before y alphabetically? Well, domain also comes before range alphabetically. So domain goes with the x's and range goes with the y. So you'll want to remember that. All right, well, let's see if we can find the domain and the range of a linear graph like this. So you've graphed lines for a long time now. You've done that since 8th grade, actually. So I want to look at the domain first. Remember, domain is x's, and your x-axis moves left to right. So we want to see how far to the left and how far to the right this graph goes. Well, if you look at it, there's an arrow on the end here. So it's going to keep going, even beyond the part that we have graphed, it's going to keep moving towards the left. So if you remember on a number line, the negative values are this way, are to the left of the origin. So this will go on forever in the negative direction. So we say that goes to negative infinity. For the domain that's on the right-hand side, if we look how far to the right this line goes, you see another arrow here. So that indicates that it's going to keep moving that way forever as well. And on another line, to the right is the positive direction, so we'd be talking about positive infinity. So the domain here can be anything. X values could be anything here. So we say that that's all real numbers. Anything is possible for this domain. It can be from negative infinity to positive infinity. Just so you know, there's a cool symbol that we use sometimes for real numbers. It's not a super big deal that you know it at this point, but it's kind of fun. It almost looks like an R, except, oh, you can't see that very well, can you? Yes. You have a double line to begin your capital R. So that means all real numbers. So a little fun fact for you. Now let's look at the range for this linear function that we have here. If we want to think about range, we're thinking about up-down movement. How far up does this move and how far down does it move? So if you look, this line is going up forever because of our arrow over here, and it's going down forever because of our arrow over here. So this is also all reals. If you want to use your fancy new symbol, the R with the double line there, you can do that. And you could say that it goes from negative infinity to positive infinity. Oops, from negative infinity to positive infinity. So I'm giving that in word form right now, but this is math class, so we need to use the language of math. I'm going to use one form that's familiar to you with inequality symbols, and then you're going to learn 2 new forms today as well. It's kind of like in English, you can say hello or sup or how are you today, and they all are forms of greetings. Well, we have different ways that we can identify domains and ranges as well, different types of language. So with inequalities for this domain, we could say, instead of saying from negative infinity to positive infinity, we could word it like this. We could say that our x's are in between negative infinity and positive infinity, and show that with inequality symbols. So the farthest to the left that you go is negative infinity. The farthest to the right you go is positive infinity. And you can never actually get to infinity because you can always go a little bit farther, a little bit farther, a little bit farther in each direction. So notice I'm using just the inequality signs, not with the equal to line under it. We'll get to that later, but you can never get to infinity. You're never quite there yet. So that's why I've chosen those symbols. So we could use that same idea down here. We could say negative infinity is less than y, because remember our range is about our y's, which is less than positive infinity. Okay, let's see what we have next here. In Algebra 1, you also looked at parabolas. So here's an example of a parabola. And let's look at the domain first. Remember, domain is left and right movement. So I want to know how far to the left and how far to the right this graph is going to go. And again, we notice some arrows here. So I am going to keep moving to the left in this graph. It's going to go really high up, but up has to do with range. So we'll talk about that later. As we move to the right, I also see an arrow, so it's going to keep going farther and farther to the right. So this actually has the same domain. Negative infinity is less than our x, which is less than positive infinity. Means it's somewhere in that number set. Now our range is your y, so it's looking how far up and how far down we go, and that's a little bit different in this case. Now let's talk about the upper part first, because I think it's easier for you to see. If you notice, we have arrows on both ends, so it's going to go up forever. But this one bottoms out. So I want to know how low does this parabola go? And if you look, we are 1, 2, 3 lines below 0. So the lowest this value goes on the y-axis, ranges your y's, is to -3. So the graph is always at -3 or above. So we could say that the y's are greater than or equal to -3. Notice I have a line under it this time because it does actually touch -3 right here on your y-axis. Okay, so that's our range for that one. Ooh, this is a fun graph. Okay, so if you look at this, we have crazy stuff happening in the middle, but we just want to look at the domain and range of it. So domain is how far to the left and how far to the right. So how far to the left does this go? Well, I'm moving to the left, and here's the farthest left that it goes. So that value would be 1, 2, 3 spaces to the left, so that would be -3. And notice there's an open circle there. Open circle means that the graph doesn't actually get to that destination. So our x values are going to be between -3 and I want to know how far right it goes. So I'm moving to the right, So here's where it ends. So that looks like it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 spaces over. Now if you notice, this end has a closed circle on it, which means it does actually touch the 6. So in our inequality, I'm writing that with the line under it. That means it's actually allowed to have a value of 6 as our domain highest value. Now let's look at the range. So range is your y's. How far up and how far down does this go? So the highest point that I can find is up here, and the lowest point that I can find is down here. How far up and how far down. So let's go with the lowest limit first. So the low end would be 1, 2, 3, 4 value, or 4 steps below 0. So that would be at a -4. And then the high end would be 1, 2, 3, 4 steps above 0. So for the range, we're looking at y's. They're going to be between -4 and +4. Let's see. Do we ever actually get up and actually hit the +4 if there's an open circle here? We don't actually get up there. So that will be a open circle. It means this will be just a less than sign on the end where the 4 is on our range. But for the lower end of our range, we have a closed circle. It does actually get to that value of -4. So that means I need to put a line under this to say that my y can actually get to -4. So there's our domain and range there. Now, I mentioned I was going to teach you some other ways of giving domain and range, how you can say these, kind of like saying, hi, how are you? Sup? Greetings from the world of mathematics. So this is inequality form right now because we're using inequality symbols, and that's the most common kind, so that's real familiar to us, like, hey, how are you? You know, that type of thing. The next one I'm going to teach you is called interval notation. Oops. An interval notation is like the sup version. It just wants to know, tell me where to start, tell me where to stop. I don't want to know a lot of extra stuff, just give me the information. So for the domain on this one, we said we could go from -infinity to +infinity. So we're going to write it like this. You're going to put the low end of the domain, and then a comma, and then the high end of the domain. And we are going to put this one in parentheses. So this is the low end, and this is the high end for our domain. Now, it's going to look a lot like an ordered pair to you. This is not an ordered pair. We're not talking x, y here. What we're talking about is the low end of the x's and the high end of the x's. And since we're talking about domain, if we use this on range, you'll be looking at the low end of the y's and the high end of the y's, okay? So a little bit different than ordered pairs. It looks like it, on this one at least. Now, there are other symbols. There are square brackets we're going to use sometimes, so I'll show you that in a little bit. But these are open parentheses, round ones, because of the fact that our inequality did not have the equal to line under it, kind of like an open circle. This is just a normal style parentheses. So this is interval notation. And then the other one that I want to show you is set notation. All right, now set notation in the language of math is the greetings from the world of math. How are you today? It's very formal. But the basis of it is the inequality that we already wrote. Okay, so here's what it's going to look like. You're going to use this fancy bracket, which I'm not very good at drawing them, so it's okay if you aren't either. And you're going to put an X, and then a bar, a straight up and down line. I'll tell you what that is in a minute. And then you're going to put the inequality. So -x is, negative infinity is less than x is less than positive infinity, and then you're going to close the fancy bracket. Okay, so now this is like speaking in full correct grammar mathematically. Okay, so it's very formal. Honestly, we don't use it all that much at this level, but you need to know it since some of you will be moving on in math. So this you read as the set of all x's. And then this bar means such that, or so that. So the set of all x's such that x is in between -infinity and positive infinity. This is the important part that communicates your domain, and we already mentioned what that was before. This set notation, where you say the set of all x's such that, just kind of formalizes it and makes it pretty. Okay, so that's what set notation looks like. So what you can do is write your inequality and then just fancy it up a little bit. Okay, so let's try that with our range. So our range here was also going from -infinity to positive infinity, so it's going to look the same for interval notation. It's going to go from -infinity to positive infinity. So that's interval notation. And then for set notation, it will be the set of all y's such that, and then I'm going to copy this inequality down here. Negative infinity is less than y is less than positive infinity. Okay. On our parabola example here, our domain was going from negative infinity to positive infinity, so that's the same. I'm not going to rewrite that part, but our range was different here. Our range here is going from, that y is greater than or equal to -3. So for our interval notation, remember that's the short version, just tell me the low, tell me the high. So we are going to go a low value of -3, and a high value, well, it goes on forever, so that would be positive infinity. Now, you can never actually get to infinity, so that's going to have a round parentheses on the end of it. However, I want to talk about this -3 end of things, because the parabola does actually get all the way down to a y value of -3. So 1, 2, 3 below the origin there. So the way that we show that in interval notation is with a square bracket. Okay, so I'm going to make a note here. The square bracket means the value can touch. So like our graph is actually going to get to -3. Never gets to infinity, but it does get to -3. Okay, so that's a little bit different. Now let's look at set notation for this. So set notation is the fancy version. So it's fancy bracket, the set of all y's such that y is greater than or equal to -3. And then close your fancy bracket. So it's the same information that you had in inequality form, just fancied up a little bit. Okay, now on this example, our domain was -3 to +6. That was how far to the left and how far to the right we moved. And so when I'm looking at that, I want to change it into interval notation. So it's going to be -3 to 6. On the -3 end of things, do you see how there's no line under it? It can't actually equal -3. What that means is I need an open parentheses here, the round kind. And on the 6 end of things, it did actually get over to the +6, so that one needs a square bracket. And then for the set notation, that would be the set of all x's such that, and then I'm going to copy the inequality down right here. -3 is less than x is less than or equal to 6. For our range, we were going from -4 to +4. So that will be in interval notation. It'll look like this. On the -4 end, it is allowed to equal it. That's because it goes all the way down. The lowest y value is -4. So that gets a square bracket. And then on the 4 end of things, it doesn't actually get as high as the 4 over here. So that one has an open parentheses on it. So, and then set notation, to finish that out, is the set of all y's such that, and then I'm going to copy the inequality down. -4 is less than or equal to y is less than 4. And then close the fancy brackets. Let's label that one so you remember how to read it. You say the set of all y's, and that bar means such that, or so that. You could say so that there. All right, now I would like you to pull out this domain and range finder that you have in your packet, and what you're going to do is cut off the 4 corners. Okay, you're just going to slice these right off here. And we'll end up with this. And this is a Pinterest project. I did not think of this by myself, but I'm really excited about it. I think they're lots of fun. So you're going to get this already. Yours won't have a graph on it yet. I'll tell you about that in a minute. But what this will do is this will help you find the domain. Domain is the left to right movement. So as you slide these arms left to right, you can see how far to the left or how far to the right our graph goes. And then range has to do with the up-down movement because range has to do with your y's. So this will tell you how far up and how far down you go. So hopefully it'll help you visualize a little bit about how to find domain and range. Now, if you were at school, I would let you use my laminated copies that are on colored paper. Very nice, aren't they? So I was a little sad that you can't actually use those, but I was driving yesterday and I thought, oh my goodness, packing tape. If you have packing tape at home, what you can do is put a piece of packing tape right over the graph here in the center, because that way you'll be able to write on it with dry erase marker and erase. So that'd be awesome. I think you can maybe rig something up with a Ziploc bag if you wanted to like cut a Ziploc bag, little plastic, and tape that over it maybe. Or just use pencil if you don't want to do those things. That's fine. Just lightly write and you can erase to do the next graph. So no problem, no big deal, but that's how you can make your domain and range finder a little bit more reusable. So the first graph I have for you is, oh goodness, if I can show you this. Sorry about this, guys. There. So pause that screen if you need to so that you can draw that on your paper. And what we want to look at is how far to the left and the right it goes. So see if you can figure that out, how far to the left and how far to the right it goes. Write it as an inequality first, and then change it into interval notation and set notation. Then when you're ready, I want you to see how far up and how far down the graph goes. That will tell you your range, because range has to do with how far up and how far down you go in the picture. Okay, so I'll give you a second to figure that out. And when you're ready, here is what I came up with here. I'm going to post these too since I'm really bad at doing this apparently. Oh wow, it's like reverse image. Oh my goodness. Okay, I'm just going to post these. Sorry about that, guys. I can't tell what I'm doing. So I will post these and you'll be able to see them. But let me give you some more to look at. So here is graph B. So you'll find the domain and range of that. Here is graph C. You'll find the domain and range of that. And here is graph D, maybe. Find the domain and range of that. So I'm imagining keeping track of your information on a sheet like this, where you have the domain and range of each of the 4 functions I have shown you. I'll upload photos of them too, I think. And so for your assignment, I want you to go ahead and submit a picture of your work for these, what the domain and range are on these 4 functions. And then I'll post an answer key too so that you can check and make sure they're making sense. Remember, ask me questions. I'm here to help you learn this material. And I know this is new as far as the how to write these things especially. So I'm here to help you ask, and you can ask away. Well, I think that's everything for today. So remember that Jesus loves you and so do I. So do your math.